what we have here is the reagent hydrogen cyanide with ethanol, and it's producing a hydroxynitrile. The thing I want to talk about first is the reagents and conditions. So hydrogen cyanide is a deadly toxic gas. So that isn't usually used directly. So instead, what you'll usually see in textbooks and examination questions is you'll sometimes see the reagents written over the top of the arrow like this, KCN with HCN, or simply for this one just with H+, or sometimes just water. The reason for this is often KCN, so potassium cyanide or sodium cyanide, is used in conjunction with acid. And then what that does is it generates HCN during the reaction. But the whole point is to produce the cyanide nucleophile in high enough concentration so it can attack the carbonyl, the dipoles I'm marking out here. So let's rewrite this equation using the potassium cyanide, hydrogen cyanide route, and then a product is going to be the same as what I've written on the top. Now the first thing I want to draw attention to is this is covalently bonded, and this is ionic. And this is important because ionic salts, group 1 salts particularly, 100% dissociate in solution to produce the positive ion and the negative ion. So you get a high concentration of K+ and Cn-. And this is exactly what you want because the cyanide ion is the nucleophile. So you want this in a high concentration to be able to react with the carbonyl compound, which in this case is ethanol. So the KCN provides the cyanide nucleophile, and then that attacks the C double bond O of the ethanol. The first thing you need to do is mark in all your dipoles. So that's delta positive, that's delta minus. Put in appropriate charges, or lone pairs on your nucleophile. So that's the cyanide. And then in the first stage, the lone pair in the cyanide is attracted to the delta positive on the carbon. That causes the C double bond O to break, and that kicks up onto there to produce. Right, in the second step, this is where the hydrogen cyanide comes in, which acts as a source of hydrogen for the oxygen to become protonated to form the hydroxy group. Okay, so you have the HCN there, which is delta positive, delta minus. Then the lone pair in the oxygen takes that hydrogen, that bond breaks, and then we finish with the product, the hydroxynitrile, which is OH, CnH, plus the Cn nucleophile is actually regenerated. So you can think of this as actually being a catalyst. So we've remade the cyanide. So that's one version of this mechanism you will see. Now let's look at where it just simply says HCN in the overall balanced equation, and then written over the top it'll be either H+ or water, okay, to form the same product. However, instead of the HCN providing the source of H+, that could either come from a water molecule or acid. So let's look. So we have CH3, C double bond O, and then the Cn again, same thing again. That's attracted to the C double bond O. Again, electrons push up onto there, and the reason why is because of this dipole, delta positive, delta minus. And then, same as before, that goes through to the second stage, where you have the CnO minus and then H. Now, depending on what's in the question, whether they've given you H+ or H2O, that would be a source of hydrogen for the next step. So let's just say they've given it as just water. A water molecule then, with the dipoles delta minus, delta positive, delta positive. The negative charge is attracted to the delta positive hydrogen. That bond breaks. And then we finish with the same product as before. How do you know which version to do? Do you do this one or do you do this one with potassium cyanide? Well, the answer to that is it depends on the question. So, when you get this in an exam paper, see what the reagents and conditions are that they've given you, and then go with the appropriate steps. So if it's potassium cyanide, then you're going to be having this potassium cyanide with hydrogen cyanide mentioned as the reagents, then this is the route you're going to go, the first one. And it will be explicit in the question, so you won't have to guess. Or if it's this one, which to be honest is the more common one, then you just go with the method I've outlined